Hi, welcome to this video. My name is Eyal. I'm from Novodes. We provide embedded software development solutions and testing. And in this video, I will show you how to test and mainly measure your coverage of your tests on your embedded software using a very nice tool called CTC Testwell by Verifysoft Technology. And I will show you how to use it with Keil uVision and basically all the process you have to go through through instrumentation and getting the serial data from the um, application while it's running on the microcontroller and um, finally generating the reports. So essentially what you need to do is start by, let me open here this folder. You need to start by installing Testwell CTC. Is just a matter of getting the relevant files and unzipping them into your computer. And you also need, if you're going to use Keil uVision, you're going to need to install another pack of files. In this case, it's Keil CTC 2.2. So once that is all installed, you'll also be receiving some files that you need to add to your project. So in this case, these files, as you can see here, are CTC Testwell, these 3C files. But it's also these header files as well. Okay, so you have these C files and header files that you need to add to your project. So the C files themselves you need to add to the project, and the header files you need to add in the include path. So essentially, you come here into Keil uVision, and as you can see, I've added it right here. Okay, the CTC Testwell, all those header files over there, and I've added the C files over here. And what you need to do mainly is, for this file, targ send, you don't need to change anything of these files except for this file, where you need to define the CTC send data. It comes with a specific template function. This is the template function that you need to help implement. I modified it a bit to fit basically my application capabilities and my hardware capabilities, but essentially you just need to get serial data and output it out. So you need to refer to your function that helps to send this serial data out. It could be some kind of printf, whatever. So in my case, I have an API function that I've created in my application called trace-C, so I'm just using this. And the buffer is something that all the instrumentation data gets sent to. And so this this is essentially it's a saved word, okay? And when you call CTC prepare upload, this is again their own function. It puts all the data into buffer. And so this file simply, this function simply prepares the information inside buffer, and then I just print it out. Now, another thing you need to take into account is that STD libraries. So in my case, I'm using a FUSA compiler, so functional safety compiler. So I have very limited STD libraries, and so to comply with functional safety, no dynamic memory allocation, stuff like that. So I was kind of worried at first how how will CTC Testwell will handle this. And essentially, they have a very good, very good ability to take that into account. So essentially, in their uh, files, if I open it here, let me see here, track data. Yeah. So essentially, they tell you if you don't have the proper std-lib or std files because you're limited, just as in my case. So you simply need to define no std-lib in the project. So you come here and up here at the bottom, at the top, you see no std-lib. So add it there, and then that's fine. Everything gets taken care of in all three files. So various things that you're asked to help implement or define, you just say, okay, just you see it's already for you. So yeah, if you need to help define this CTC alloc, but again, I can't use malloc. So this is already prepared for you. So you just set nose to the lib, and so it just does this automatically. And you have various other cases like this in their files. So very convenient, and it works pretty well. And another thing that you need to take into account is how, where does all this information come from that it comes to be printed out. So again, let me just take a step back. What CTC, what all coverage tools do, they do a step called instrumentation, right? So that means they insert their own code, coverage code, inside your own code, where it essentially helps to identify where your code goes during runtime. And this information gets in real time gets sent or packed into this buffer, and you need to print it out so that you can collect it on your PC and then run an analysis on that data with their tool. And I'll show you soon how to do that. And you finally get the report as to where your tests managed to go to within the code. What did you cover specifically? And you have various types of coverage, by the way, supported by CTC. I will show you specifically type of coverage called statement coverage, or also known as line coverage, and decision coverage as well. They're both supported at the same time. The more complex your coverage type is, then the more memory it consumes, because more instrumentation is required. And given that I do have limitations in my microcontroller, as many do, then it was a choice as to what type of coverage I could use. And so I went with what I could, and which is decision coverage, and not the most extreme one, which is supported by them, which is multi-decision coverage. So in any case, the methodology of also printing out all the information is one aspect of their implementation. They also have another way of collecting the data in real time, which is by, instead of printing it, you can also choose to store it somewhere in your flash. That actually is more efficient, but it's also much more complicated to implement. And I'm not sure it's too complicated, but just a little bit more. So then again, but they have really great support. But I managed to, with their support, to just get the printing from serial going, and it worked great. So what you need also to do is define where, when this function gets called. So in my test, let's say in my test runner, okay, in my unit test framework, which is a customized unit test framework, I have it here under this function here. And let me see here, under, wait for a second. This is all we need to do. So we just need to add at the end of every test that I have, it uses this API, okay, where it has a setup, run test, tear down. So this goes through every test in the test files that I have. And so at the end, you just simply need to add this line, pragma CTC append, which is something that they tell you to add. And that this essentially calls every time CTC send data and also appends or populates the buffer all the time with information that can be sent. So that's the link between this is the link between their files and our tests. That's how the link occurs. And then you simply load it. Sorry, not so simple. You first need to build the project. So, and when you build it, you need to generate a batch file. Okay. So you need to create a batch file. You have to have this selected. And so you click build. Now that we finish this build, we have the bat file. We can run the instrumentation phase. So we're going to use this file to do the instrumentation. So to run the instrumentation, we just open CMD here in this same folder, and we're going to run this command. Okay, so we're going to run the call Keil CTC -id. D defines the type of coverage that we want, which is decision coverage, and on this bat file. Now, before I run this, I also want to explain one more thing. There is a file within CTC, within the where we installed it. It's called. Let me find it here. There we go. CTC Keil INI. Okay, so let me open this for a moment. So here, what we want to do is under, they have various targets here. So we're using our claim, our CLang, depending on you find it. And you want to define which files you want to instrument. Now, as you saw in our project, we have a lot of files. Very full. I don't want to instrument everything. I won't have even memory enough to instrument everything. I want to instrument only what really matters to me, which is the files that I use and develop myself that I truly want to test at this moment. I have other files here that are from third parties and stuff like that. I don't want to test them. So I'm going to test only the source files of this folder. Okay. So in order to do that, what I do, again, I'm going to go to this file this I created, that I opened from CTC. And under, as I showed you, under our CLang, we go down and you find this exclude pattern. I'm going to have a bunch of other stuff here that I tried previously. I'm just going to remove that. Okay. So as you can see, I only have here middleware, source files, and I have this file simple test CPP, which contained, as you remember, that pragma. Okay, so in order to develop this into the proper call to this function, this is done by their own tool later during the instrumentation phase. So you need to include this in this file in the instrumentation, which is simple test CPP. So this is what you need to find here. I'm going to save that. Just going to save this for future reference. All right. And now I can continue with my CMD command, enter. essentially going over every line there in that bat file and instrumenting it. All right, so now that the instrumentation phase has finished, there are still some issues. As you can see here, this command is too long. There's some issue with when this command is being run. This is taken from my bat file. When this command is being run, essentially with their tool, there's some kind of problem. So I'm just going to run it myself here, which is fine. And this has been done together with their support, so I know that it's fine. So I just run it here. And as you can see, it gave me the program size information. And now I'm going to create the X file, copy paste this as well. And finally, the bin file. Okay, done. And while I did this, in this folder where I ran the script, I got this mon.sim file, which is used later on to identify and connect all the instrumentation data that I get through the serial information from the microcontroller later. Okay, so now I did generate the hex file. It's located where it's typically located when I build a project through uVision Keil. It's the same place, and I'll just load it to the target. So I'm going to open QProgrammer for STM32. And open file. As you can see, it's right here from right now. Just verified it. Great. Connect to the target. Connected and download file. You also want to make sure that no other serial data will be printed from the microcontroller. It will just generate noise for you and perhaps for the tool that will later analyze the serial data. Will save you the effort trying to take the coverage data and the other typical serial data that you have and trying to separate them. So just don't put anything else except for the coverage data. So I already took care of that in my code. Disconnect. And I'm going to open now. My serial terminal. Here it is. And I'm going to use any timestamp. And I'm just going to reset my board. I have it over here and start seeing the information being set in a second. Okay. And my serial, this is a customized serial terminal. So I have it both in Windows user interface and both console. Why? For my own reasons. But anyway, just going to take a while for all the tests to run. All right. So now all the serial data has been received. Okay, all of this, which looks like gibberish, I know, is the coverage information. I'm just going to copy all this. And right here, I'm going to create another file. Call it mon.txt. Yeah. And paste all the information here. Save. Okay. Go back to CMD. Now, going to run following command ctc-2det. And this is going to create, this is going to essentially sort of link the coverage data that was received with the instrumentation that was created. So it's going to link basically these two files, mon.sim and mon.txt. Enter. It creates this mon.dat file. Yeah. if there's any issues with the serial data that was received, you will typically receive here an indication saying, hey, you had 1, 2, 20, how many, whatever, you could say modules that were corrupted. But given that no such message has been received here at the end, I know that all the data, serial data, was fine. So now I just want to see the report. So I can type CTC report. Now I got this. So remember originally I told you about the simple test instrumentation. So it was for simple test CPP, was just for that linkage. I don't care about that. All I care about is this file, all these files. These are the middleware files, which I'll soon analyze. But you can see here the summary, which tells me I have of those files, okay, including this one, but this is really minority. So its effect on the total statistics is negligible. But essentially 60% of the code that I wanted to measure, its coverage has been covered, only 60% in terms of statement coverage, 45% in terms of decision coverage. And if I open this, you can see for every file, I can see the how well it's doing in terms of decision, how well it's doing in terms of statement. So like, for example, base operation module, so it has 100% decision and statement coverage. And while for base unit, I have 100% statement coverage, but only 75% decision coverage. Okay. And you can click on every item and see what's going on. And you can see here this function, for example, and you can see on the left here that every line that is green means it's been covered, and if it's something that's red, it's not been covered. So this means here that this item here has always been true twice. It was reached here twice. Both cases was true. It never tested when this was false. This is what it means. That's why it's red. So if you're reaching for decision coverage, getting it to 100%, you need to test this function also where this is false. Okay? That's what it means. And so, but in terms of statement coverage, it's perfectly fine. Everything is green. But if I go to another file, let's say, I don't know, let's go something with like 50%. Let's say this one. So you can see that many lines here are red, some are green. So it's not been tested fully and requires a lot of improvement, both in terms of decision and statement coverage. And so this is a very powerful tool. You get a really good visibility into your code and what's going on. And yeah, I highly recommend it. It was very easy to use, very straightforward, relatively. I mean, compared to other other strong tools out there. Like for example, Verifysoft, they have a tool called, I forgot its name, but Verifysoft has a great unit testing tool, and so does QA Systems at Cantata. And they're really powerful. So they are not only coverage measuring tools, they're also unit testing tools. The problem with those tools is that in order to get them to work on the target, it's typically not that straightforward, and it requires a lot of effort, and with the help of the company, oftentimes paid effort. Yeah. And well, in this case, at no cost with Testwell, and maybe just I think 1 hour at most of support, and I got it going. So really efficient, and really happy with the results. Very powerful.